All right, so good morning again. My name is Mohammed Al-Kuli. I'm an interventional cardiologist at Mayo Clinic in Rochester. It's my honor and privilege to welcome Dr. Henning Anderson, a pioneer in our field, the inventor of TAVI, or TAVR as we call it in the US. He's joining us from Denmark to tell us about the journey of TAVI from beginning till now. We're also honored to welcome Dr. David Holmes, another legend in cardiology who needs no introduction, past president of HCC, and he's actually joining us from Johannesburg in South Africa now. So good evening, I would say, Dr. Holmes.
Good morning to you. Good evening from here. Can
Thank
you hear me okay?
We hear you very well. Thank you.
Good.
So
thank you for the chance.
No, this is great for us to be able to join this morning. Dr. Anderson, I think before we get started, I was just going to play a 50-second of a clip from a video that you previously recorded just to, kickstart the journey and tell people about how TAVI started, and then we'll start asking questions. Okay. Well, for attendees, please, we would like this to be interactive. So if you have any questions, you could type them in the chat box, or you could add it on Twitter, and we'll ask Dr. Anderson. It will be recorded and it will be posted on YouTube in a couple of days as well. So without further ado, I will just start by showing you this this clip.
Can I say hi to Henning?
Please.
Hi. Hi, David.
How are you? It's nice to see you. It's been a long time, but boy, it's been an adventuresome time for you, and it's wonderful to have you on the program. I can remember hearing you very early on, and it looked like it was going to be tremendous. And then all the things that you went through them and got over them. And so that early idea that we had talked about, that I listened to, and as I heard it, and then I think I gave you a thumbs up, because I thought it was just terrific.
I remember in Atlanta, you were the chairman when I presented the Dynamic 2 trial, and you gave me a thumbs up.
So it was an exciting time for you. It was an exciting time for patients, for the field. But congratulations again. I'm sorry, I didn't mean to break in. Go ahead, Mohammed.
No, thank you. This is perfect. This is great. Thank you. So this is how Dr. Anderson describing how he started with the journey, and then we'll hear it from him firsthand.
TAVI i 1989 under et møde i Scottsdale i Arizona. Jeg sad i auditoriet og hørte på forskere, som viste, hvordan man kunne sætte stent ind i koronararterierne. Pludselig fik jeg den idé, hvorfor laver du ikke stenten 10 gange så stor? Så i stedet for, at den er 3 mm, så bliver den 30 mm. Udviklingen af hjerteklappen, den foregik de første år i vores eksperimentelle laboratorium nede hos grisene. Jeg nåede at indsætte, og i alt indsatte vi 40 hjerteklapper på grisene. På det tidspunkt var der ikke rigtig nogen stadigvæk, der troede så meget på ideen ud over mig selv. Det var svært at skaffe midler og få industrien interesseret i at udvikle den her teknik. Derfor gik det i stå.
So, Dr. Anderson, you were in Arizona in 1989, and you were in training, if I understand correctly. Yes. And it was like an aha moment. You're listening to somebody talking about coronary stents, and the simplicity of the idea. I was like, okay, why don't we make this bigger and make it a stent? Can you describe that particular time when you were thinking about it, and the subsequent days?
Yeah. 1 year before that time, I was in internal medicine. I was not even in cardiology. I knew that I wanted to be an interventional cardiologist, but I was still training in internal medicine. So I had a position in the Department of Cardiology. They offered me a position as a researcher. And the reason why I ended up in Arizona was that my clinical professor, he got an invitation, but he didn't have the time to go there. So he went to me and said, Henning, why don't you go on behalf of me to Arizona to this conference? And I did.
So a medicine intern who just started the research program before cardiology
Yeah,
who happened to go to the conference accidentally on behalf of the
of
mentor.
my professor. Yeah.
Nice.
So the concept of serendipity is live and well.
Yeah, it is. It is. So okay, you were listening to the talk and you thought that, why don't we make it bigger?
Yeah.
And what was striking there is that I think that conference was somewhere in May, and by the end of the year you've already done the studies or
Oh, yeah.
started doing the studies. So how did that happen? I mean, you thought of the concept, you probably lost sleep over it for a little bit, you went back home, and describe what happened then.
Yeah, it was quite easy. When you get such an idea, a crazy idea, it's really a crazy idea. And at the same time, you have a crazy brain. These two things matches. So you just move forward. And, the man who presented the animal experiments, he was the inventor of the balloon expandable coronary stents. He was the first in the world to implant that. So while I was listening to him after I got the idea, and the idea took me 1 second, I said, Henning, you want to be the first person in the world to implant artificial heart valves without surgery. It was a simple thing.
So what then so you start with an amazing idea and the light has gone on. So you then are on the airplane going back home. Who's the first person that you then say, I've got this amazing idea.
Yeah.
What do you think about it? Who do you run it by?
Yeah, very good question. Because when I came home the day after I arrived in Denmark, I went to my clinical professor and wanted to say thank you to him because he sent me over there on his ticket. And then I told him that I got this crazy idea. And of course, he said to me, like everybody else would say, that it can never be done. It's impossible. But he was open-minded. So he said, but Henning, give it a shot.
And so what did that mean to you when he said, it is crazy, but give it a shot, go ahead with it? How do you take then the next steps?
It is fantastic when your professor tells you as a young physician coming from internal medicine, going into such a program, and when I served such a crazy idea for him, he was open-minded. I say, give it a shot. It's the best words you can get from your professor. Give it a shot.
But what does that have, implications in terms of, funding? And so what happened next? Give it a shot. Did you have, I mean, you had just started this research tenure and you didn't have any experience in cardiology. You don't know much about valves and stuff.
No,
So
that's right.
what were the next steps?
I think that the importance of these words from my professor was that it opened the doors inside my own department. And that's important because, I got the support from my professor, which meant that when I went to the animal lab, and it was not an animal lab for cardiologists, but my professor opened the door. When I wanted to take the pigs into the clinical lab, and sometimes I wanted because the X-ray equipment was up there, then I knocked the door of my professor and said, is it okay that I take the pigs up in the clinical lab? Oh yeah, he said. What about the hygiene committee of the hospital? Do we have to apply for permission? Just do it, he said. That kind of support is very important.
So that's the concept of ask for permission later. Just do it right now. No.
I think I forgot to ask for permission.
Right.
Okay. Okay. Great. So
sometimes you should just do things. Don't ask permission, just do it.
Right.
So tell us then, the first valve, the first experiment, how did you make the valve? Who helped you? How long that was after the conference?
Yeah. I started within 1 week after the conference. Initially, I thought that I had to make contacts to some of the big companies and ask them to give me access to some kind of metal stents. I found out that it was impossible. You know, nobody was really interested in supporting a young physician trained in medicine to do cardiology stents. So I decided very, very fast that I had to build it myself. I have seen something in Arizona. I said, okay, Henning, you can do it yourself. So I simply went to the different hardware shops in the city, you know, and got metal wire, steel, and things like that. You should remember, this is before the internet was invented. There was nothing called Google. So you had to find out yourself.
Amazing. 1 week, right? So you gave yourself 1 week, and in this 1 week you made contacts and it wasn't helping. So you decided to just go to the market.
Myself. Yeah.
Okay.
You described then at that point in time where you took the various wires, you settled on stainless steel from the hospital after having been to Hardware Hank. We talk about Hardware Hank. That's one you have an equivalent of Hardware Hank, but you had been around to those places.
Yeah.
And then you were then able to just by feel get a sense of what they should feel like, or and then you
exactly.
did 2 loops and then a third loop.
You know, it's something with your fingers. You know, I didn't have an engineer. I didn't have a company to help me. I didn't have a fancy things where I could measure all these fancy things. You know, and I didn't really care. You know, you think you want to be the first in the world, Henning. Don't care about all these small technical details. Just go for it. So I simply, you know, had the imagination about how stiff should it be, how soft should it be. It should be able to be aided by a balloon, but it should not have too much spontaneous recoil. You know, it was a feeling about what do I want. So I said 10%. So it should be able to be dilated up to 90% when the balloon was inflated, and it was not allowed to have more than 10% recoil when the balloon was deflated. It was simple thinking.
So what background had you studied in, for instance, in university, that you would know some things about compression and things like that? Did you study engineering in some way, or
no,
physics in some way?
No, never. It was no. I grew up on the countryside in a farm family, and when you grow up such a place, you learn about how to use your hands.
Can you tell us then, what did your family think about a crazy idea and a crazed person who then spent day and night thinking about it and puttering around? Can you tell us a little bit about those things? Because they're very important.
Sometimes they thought that this was too much. You know, I came home late in the evening, smelling of pigs, and you know, it was not always very welcome. But on the other hand, I wanted to do it, and they accepted it. You know, at that time I was a young man. I was 30, 35. You know, and we could tolerate a lot of things, including my kids. I had my kids in the animal lab this time, sometimes in the evening.
They must have loved that. That must have been phenomenally great in showing what Dad is doing with all these great things and having some animals around. Oh my goodness, must have been the best.
It was the best. I still have a picture of them then. My daughters were around 5 or 6 or 7. You know, the most important thing for them was to keep your fingers on their nose, because the smell of the pig. It was to have them.
That is terrific.
It's a very important what you just talked about. You know, you didn't have an engineering background. You really didn't know much about how to make it. There were no internet. You didn't have anybody guiding you, but you had, you know, unimaginable urge that you want to be the first and you want to do it, right?
I think that's thinking about. I have seen Julio Palmas, the inventor of the balloon expandable stent. You know, he was the first in the world. And while I was sitting there, and when I got the idea, I said to myself, I want to be the first, like he is the first. It was my driver.
So then two questions come up here. One is, you know, when you come up with a crazy idea, as you said, and you don't have much of background and context, you know, in industry, they say prototype and iterate. You don't have to make the first prototype good. You just want to make it, I mean, acceptable enough to proceed. So I think you just illustrated that very elegantly here. But you know, so that's one question. How much should I know about something to be able to invent in that area? And the second question is, you know, people, there's now, obviously it's different now, but when people have new ideas, they're like, oh, should I disclose the idea? Should I tell anybody about it? Well, maybe I should protect it. Maybe I should evolve it to a stage where, you know, it's much more sound and reasonable before I talk about it. So maybe either you or Dr. Holmes or both can comment on that. I mean, for us, for younger, you know, people who are trying to come up with ideas now, how much knowledge do I need or can I come up with an idea in an area that is completely nascent to me or foreign to me?
I
I
think
think you should take that.
sorry?
You should comment on that. And then there are a whole bunch of other things to comment on. Perhaps before you comment on that, in your magnificent article that you've written about it, and Mohammed, does everybody on the audience have the citation for that?
Yeah, I will post it. I had posted it before, but after we record this, I will post it along with the video. So Dr. Anderson has written his journey in a very amazing details from the beginning. So we'll post that so you could have access to it if you want to even know more details.
But even before you got home, you were thinking about it, because on the flight, in your article, you describe on the flight back to Denmark, those things that you wanted, those were the requirements that you were looking for before you'd even gone to the hardware store, Hardware Hank. Those 5 things, and I'll just mention those and you can comment on, it had to be performed by retrograde catheterization, had to be a closed chest procedure, it had to be a closed heart procedure, had to be a beating heart procedure. So closed chest, closed heart, beating heart, performed without bypass. And so already you had an idea of what indeed this thing would look like, whatever the thing was going to be. That's what you wanted it to do.
I think that after my idea in Phoenix, Arizona, I still had 1 or 2 extra days over there before my flight back home. So I think this thinking was maturing in my brain. I remember that when I was sitting on the flight back home to Denmark, I had a napkin, and on this napkin, I wrote these different requirements. I cannot find this napkin anymore, but I still remember that I was sitting writing these requirements on a napkin back home.
Gosh, the napkin karma, Dr. Holmes. Can you tell us about the napkin?
Sure. So Mohammed and I had talked about this in the space of left atrial appendage occlusion. So there is a napkin. I know where we wrote on the napkin. I know the place where it was. I know the time of day where we wrote about it, and then designed on the napkin what left atrial appendage occlusion would look like. And that was the napkin. Now, to my horror, I still now can't find it. I remember it vividly. I remember the table. I remember who I was with. I remember everything about it, except that little napkin, which was in a Marriott lounge outside of the airport in Minneapolis. That was where we put it down.
Exactly.
So it's the napkin story all over again.
Napkins are very, very important in research.
And for people on the audience, those napkins are incredibly important. They help you refine things, number one. They help you start the process, number two. And all of those things should be saved like the rarest of gold or the rarest of jewels, because they then tie you to where it started and your ideas and your vision about it. And so the napkin idea that Henning has just talked about is absolutely fantastic. It's really fantastic.
And now, you know, our phones are all have cameras now. So if you draw on a napkin, take a picture right away. So in case
Yeah.
napkin
I
gets
cannot find it. I have looked in my library, but I cannot find it anymore. I don't know what it is.
great. So we have a lot of questions to cover. We have a great comment from one of the audience who happened to be a cardiac surgeon. So Dr. Joyce says, surgeons knew a lot about heart valves, but were trapped by their knowledge and could not believe that such a device would work. I am a heart surgeon. So that you know, highlights this issue that if an outsider who doesn't necessarily have too much depth and of a knowledge in a field may avoid the tunnel vision and proceed. So tell us more now about the next steps. Of course, so you designed your own valve, you mounted the valve on a balloon. How was that first animal study? Was it successful, not successful? What did you learn from the first pig that you've done? And how long after the idea that was?
First of all, I want to comment on what you told us just before. If any of you have read the book from Thomas Kuhn. Thomas Kuhn is the US professor who came up with the definition of paradigm shifts. He was at MIT, at Princeton, at Berkeley, back to Harvard. He was very good. He said that, who are the guys who come up with such disruptive ideas? It is the young people who has not been formed yet. They don't know a lot about it, but they are so open-minded that they just think about it without speculating about all the problems. Whereas when you reach the same age as me and David, you know, you are the world specialist. And if a young guy comes to you and say, I want to put artificial heart valves in by Canada without doing operation, both me and David would probably say, no, it's impossible. So be a young person.
Well, I think maybe I could attest to that because I do share the same office with Dr. Holmes. I think youth is in the heart, not by age. And he continues to come up with so and so crazy ideas till today that I feel that are more for my age. So I think
very good.
I think age is in the heart. So was the first animal study successful or was it not?
When I started, one of the problems was that I didn't have approval from the animal ethical committee. You know, when you start to do animal research, normally you need funding to buy the animals. You need approval from the animal ethical committee, but I could not wait for that. So I started to cooperate with a cardiac surgeon. And this cardiac surgeon, he was under training. He was also a young doctor. He was on training. He already did animal research. And he had an approved animal protocol for implanting heart valves in pigs. So we just decided that we used his approval. It was already approved for heart valve implantation in pigs. The difference was that he opened the chest. I wanted to do it by Canada, but you know, we just did it because we didn't feel that we have a big ethical problem. And then I filed for an application, but it lasted a long time before I got it. So this was the start.
So when was the first animal study?
The first animal was what we call pilot studies, because doing this procedure, if you have read the paper, you can see it was very complicated. We have to open all the abdomen, go into the aorta. So there was a lot of training just doing the procedures. So for the first 6 pigs, we didn't even try really to implant the valve. We simply trained the procedure, removed the kidneys, removed the spleen, removed the intestine, sew on the graft. You know, sometimes these kids, or sorry, pigs, they died from bleeding because it was such an extensive. But you know, instead of starting up and have failure, just better go small steps, learn your procedure. So this was how we started.
So you did 6 animals just to get access and learn how
just to train, to open, to, you know, we don't have veterinarian doctors. We have to do the intubation of the animals, the ventilator, the sedation, you know, we have to learn everything.
So the cardiac surgeon trainee must have believed in the idea strongly.
He did. He was as crazy as me.
Okay.
So at what point in time during this time did you then begin to record the results of these things? What you had done, how you had done it, all those details.
Yeah.
When did that, you talked about the light going on in terms of the initial concept. At some point in time, you must have said, we're going to have to start to make some recordings of this, because otherwise
Exactly.
we
yeah.
won't either remember
From-
them or something.
From the very beginning, to get approval to go into the animal lab from the professor of the animal lab, you have to come up with a protocol. And this protocol says the first 6 animals is for training. And after the first 6 animals have been done, then we start a real research program. And from animal number 7, we had a formal research protocol which say you should do this, you should do this, you should do this. Sometimes we were successful, sometimes we were not successful. The very first pig, which was in the protocol, we were successful. I was lucky. So the first 6 animals only for training. After that, 41 animals implanted.
That process that you described cannot be emphasized enough. To be thinking about the specific protocols that you're going to use, the questions that you're going to answer, and set out the problems that you experience. That cannot be overemphasized. Everybody on this call that is interested in bringing along new ideas need to remember that, write that down, imprint that on your memories, because Henning, that was a great statement of what you did, because most people wouldn't necessarily know what you did. Now we know what you did.
I still have, after each experiment, I wrote, of course, there were standard schemes, but I wrote a protocol about everything. I still have these old protocols 30 years ago.
That is phenomenal.
So Dr. Anderson, you did over 40 animals and you implanted valves in all these 40.
I tried to implant valves in all 40. Sometimes the valve embolized. Sometimes the balloon exploded, because these balloons, they were second-hand balloons after have been used in patients. They were very stiff, very fragile, because they contained X-ray fluid. So there was a lot of mistakes, because the balloon was second-hand balloons. The aortic annulus of the pig didn't fit with the size of balloon I had. So therefore, if I only had a small balloon, then the valve embolized. So there was, all these small practical things.
But
So
within
it was learning by doing.
Within the limitations, I mean, you didn't really have the proper size balloons. I could tell that now, until now, you didn't have any specific funding.
No.
So without funding, you did 40 animals with leftovers.
Yeah, but my cardiac surgery colleague, he had the approval and he had the funding.
He had the funding for the animal, to pay for the animal.
He had the funding for the animals, yeah.
But
We don't pay for the animal lab.
Yeah, but you didn't have any funding for equipment. Those were left over.
No. I had to, how should I say it in a nice way? I have to borrow it from the department.
So the phrase that is sometimes used in that regard is beg, borrow, and if need be, steal. I'm not suggesting that you did any of those things other than beg and borrow.
Well, great. So now, after the 40 animals, how many of those were considered like success? The valve stayed in and you could demonstrate?
I think that basically successful, only 50%. Yeah, because there was sometimes I ended up with 2 valves. The first valve, embolized and went into the descending aorta. Then I put a balloon in, expanded it, and took another one and put it in the right place. But it was not the protocol.
Right.
So the first one was a failure, and then I just wanted to put a proper valve in.
How long did that take to do the 40 animals? A year, 2?
Oh yeah, it took me a little bit more than a year, more than a year.
And when was the first time then you wrote something up, like a case report or that abstract? And I think I'm going to tell the audience that Dr. Anderson still hangs the abstract on the wall. Can we see it?
Let's see.
That is the original TAVI abstract.
This is the poster from American Heart Meeting in New Orleans in 1992.
Right. If you guys have not seen this before, it's amazing that it's still around. All right. So now, when was the first time you wrote something up?
I think that the very first presentation of this invention was at the 30-year anniversary of the Danish Society of Cardiology. And I remember that I filed my patent the day before I presented. So my patent was filed the 18th of June, I think, and then I presented the 19th of June. That's very important for inventors. Don't go on the podium and tell or publish before you have a patent application. Otherwise, the companies will just steal from you.
That cannot be, again, emphasized enough. Before there's any mention in the literature or any mention at a meeting, you have to have set in place a patent application, because Henning is exactly right. Otherwise, it can be invalidated.
It can. And if the companies out there find out it might be a good idea, they simply steal it from you.
Mm-hmm.
They are, they are rough.
Maybe we want to spend the second half of the talk dedicated to that. But before, I know that it took you a couple of years to get a case report accepted, and in your article, you even published the response from Jack and from Circulation, and how they felt it was low impact and stuff. Can you tell us just about that, and what should people who are working with journals now look for when, I mean, you didn't have a lot of data, but it was a disruptive idea. So what can you tell us about that?
Mm-hmm. I think that you should never ever give up. If you really believe in your idea, you should continue. And there will be a lot of people who tell you that this can never be done, because it's so easy to speculate about all the problems. The heart valves, there will be endocarditis. They will break down within the first 1 year. I think, questions like that, don't listen to it. Just go for your goal. And my goal was only to do proof of concept. I decided from the beginning, I built everything myself. The operations was not sterile, the metal was not sterile, the valves was bought in a butcher shop, and they were not sterile. These animals, they could only survive for a few hours, because otherwise they will have sepsis, But everybody told me that this is completely impossible. They will die, they'll have sepsis, they cannot survive for 1 year. They're right, but I don't care. I just wanted to make proof of concept. Can it be done? Yes or no?
Was there any outlier? Was there any person, a spouse, a family member, a friend, or anybody who told you this is not crazy?
Maybe the professor of the animal lab. He was not my own professor. He was very, very open-minded. Of course, he said the same, this can never be done, but give it a shot. And then my young cardiac surgery colleague who joined me we ended up being 3 persons, me, the cardiac surgeon, and a young medical student. We worked together and did the procedures. The 3 of us, we were believers, strong believers.
When your surgical colleague, how did he then interact during this time with the established surgeons? Was it apparent to the surgical community that you were working on an interesting sort of crazy idea, or did the 3 of you say, we're going to wait until we have a little bit more stuff to talk about it?
He was a good friend of mine already before, and we did research together. I knew that he was working in the animal lab with heart valve implantation. So I actually made contact to him because there was many things I didn't understand. First of all, I needed a person skilled in surgery. I could not do all that huge surgery myself. I was a medical doctor, trained in medicine. I could not do the surgical procedure, put on vascular graft. So I needed a skilled surgeon. And he was a very good friend of mine. So that was where this part started. Then he taught me how to mount a biological valve inside the stents. I was not aware about the 3 hinge points. You know, the 3 hinge points of a biological valve, you know, to create the right structure of it. And he was the guy who told me how to cut these valves from the butcher's shop and how to mount the hinge points. So it was a cooperation. Yes, he was. There was a lot of cardiac surgeons in my hospital, still are, and they just shake their head. Initially, they hated this cardiologist because he thought that he could put in artificial heart valves. One of my very good colleagues, he later became a colleague in the Cleveland Clinic. He said, "Henning, this is like going to the toilet. You are trying to get the valve up the opposite way around into the toilet."
Gosh. Well, so Henning, then after that, okay, you did the 40 animals, you've submitted, you've had multiple rejections from journals, and eventually you got accepted to European Heart Journal as a case report. That remains one of the highest cited case reports ever written in cardiology. And then, but you've already filed the patent then. So you did everything right. I mean, you right and at a light speed. Yet the consequences, I guess the story, I mean, so far it's inspiring, but it becomes a little bit demoralizing from here. After you filed the patent, you got a hold of a startup company who licensed the patent, and things did not go as well from here. Do you mind sharing what can be shared from here and what lessons can we learn?
Yeah. When I filed the patent application, I ended up having to pay myself for the applications from my private economy. Then when I showed this poster, showed you just a while ago, there was a company called Stanford Surgical Technologies. They came and looked at my poster and said, "Henning, do you want to sell your patent?" And I said, "No, I don't want to sell my patent. You can license it." And then they ended up licensing my patent. What they didn't tell me was that they had just made their own private invention, and they have applied for patents on it. And it was the invention about port access surgery, which is minimal invasive surgery for the heart. And they saw my invention as a competitor. They simply didn't want this invention to be developed, and they didn't want another company to have it. So I ended up giving them a license, and I didn't earn only a tiny bit of money. And what they did was that they put this application into the drawer and kept it away for 7 years so that nobody got hand of it, and they didn't develop anything themselves. That was what happened. So they were simply afraid of my idea.
So that's how, you know, how could you have known about? That's the problem. I mean, you've done everything right, and then you know, if you go back now, do you think you would have researched, you know, a little bit more? I know that the resources were limited and you didn't have the money to take it further, and the big companies didn't believe in it. So this is what you had. But what would you do differently if you know not what you know now and you go back?
Yeah, I would, first of all, I would have done more research about this company. When I entered into this license agreement, I didn't know that it was basically built by cardiac surgeons. I didn't know that what they have invented. And I didn't imagine that they would never do anything to it. I went to their company. It was in the Bay Area in California they were located. And I was there twice. Oh, they promised me that now they will build my valve. They had already promised me to give me new sterile valves and catheters within 6 months. But they never did. They just, you know, tried to make the time go. So I will do 2 things today. One, do more research on the company. You can do that yourself, most of it. And second, I should have had my own lawyer.
Yeah.
This
So you did.
small company had their own lawyer. And when it was he who formulated the license agreement, and I was cheated, no doubt.
So did you review the license with anybody, or you just did it on your own?
No, I did it together with an advisor in Denmark. He was not a lawyer.
So there was no lawyer.
But, you know, I didn't. For example, if I was a lawyer today, I would have required that this company should prove they developed my idea, and they should have some milestones. After 1 year, support me with 100 heart valves. After 2 years, make them sterile so I can go on with my research. And I forgot that. Therefore, this company could put everything in the drawer for 7 years without having the obligation to develop anything.
Right.
I would never allow that today.
And also for the audience, maybe it's important to know that, you know, even though you had a professor who he was not mentoring you on this project because he was the animal lab professor, and you're sort of on your own.
Yeah, I was basically on my own. Yeah.
You're on your own scientifically, you're on your own administratively, you're on your own economically, right? So that was the problem. So 7 years, they put it in the drawer to kill it, which is pretty demoralizing. But what did you do in those 7 years? How was it? I mean, it must have felt amazing the first couple of years to see how things are progressing despite the challenges, and then 7 years of nothing. So what were you doing? How did you feel?
In the beginning, I was very confused. I was there visiting them twice in California. As I said, I promised to do everything. But we had not finished the license agreement. And every year when the time for renewing the patent applications, then they prolong these discussions. So my applications nearly expired. I ended up the last time, I had to go to the bank and take loans in my private house. So I could pay for 1 year extra year for application of my patents. So it was the kind of business. This company wanted two things: either all patent applications expire, then they don't have an enemy, or get my patent applications and put them away. It was the two goals for the company. I can see that afterwards.
And you had to go for training at that time, right? You completed.
Oh yeah, I was working during daytime.
So tell us then, how did you balance the fact that you were working with all of these things? Some of it you could do on weekends and nights and things like that, but you still had a full-time job.
I had a full-time job, yeah.
How do you do that? Or tell the people on the call, because they'll be faced with the same things. They're going to have daytime jobs, and this is a wonderful dream. How do you balance that?
I think that in Denmark, young doctors does not work as many hours like in the US. I think my weekly job was around 50 hours a week. Then you have the rest of the day off. So I think in US, you work 60, 70 hours per week, right?
That was in the past. I think we're now more Danish than
Congratulations.
Well, okay, so 7 years of, you know, the company dragging their feet and nothing is moving. And what happened at the end of the 7 years?
Oh yeah, then a lot of things happened. There was another company coming up who had heard about it, my idea, and the founder of that company is called DVT. He was the research chief in Johnson & Johnson. I have actually contacted this guy a couple of years before. I said, why don't you buy this stupid small Stanford Surgical Technology company? Then you have a beautiful patent. And he had to ask permission at the board of directors in Johnson & Johnson, and they said no, they were not interested. So he broke from the company, formed his own company, Percutaneous Valve Technologies, and then he bought the patent from this Stanford Surgical Technology. And then it started to move. But then a lot of strange things happened, which I, as a researcher, don't understand, because suddenly my patent was in Johnson & Johnson, not in the other company. And the patent was transferred to a subgroup called Ethicon, which is a sub-company of Johnson & Johnson. But the license agreement ended up at PVT. So suddenly my patent was spread into 3 or 4 different companies.
And who was your contact at this point? Like anybody keeping this?
I didn't really understand, so I approached all of them. Said, what the hell are you doing?
And then what happened? So PVT took the license. Apparently,
Yeah.
There is the company that developed the technology.
It was.
Were you involved in the development?
Yeah, I was because it was PVT. We have to credit PVT for doing the major work. And this Stanton Rowe, this is his name, the director of PVT. He was actually a very great guy. So he also invited me to be part. Much of the development of a stent was performed in Israel, in Tel Aviv, and I was there in Tel Aviv. Many of the animal experiments was done by Professor Alain Crébier in Paris. I was in Paris together with Crébier and participated in animal implants. Martin Leon was on board this company, and I was a part of it from a non-financial point of view. I participated. I came up with my advices and my ideas, so I was a part of it. Yeah.
So was there a consideration to be a participant also from a financial standpoint, because it was your idea to start with?
Yeah, I had this idea, but the other guys didn't.
Okay, then that's it, right. I think that's a terribly important point in all of these things, is to make sure that it's written down what the specific roles and responsibilities are. The more that you can write that down and then say, these are the metrics for performance. For this year, we're going to do this, and that year. But I think the more that you can be concrete in writing those things down, the better. It doesn't guarantee everything, as you found, but it's perhaps the best thing that you can do for sure to begin with throughout. And you did that very well.
So you did cross paths then with Alain Crébier, because when people talk about the first TAVI, everybody remembers his name, right? So
we did animal experiments in Paris. He doesn't use pigs; he used sheep.
I see. Okay.
But it was a lot of fun.
Great. So it seems like now we have a question from the audience saying, how different was it then and now to pursue an idea? It seems more difficult now, although there's more access to knowledge, there's internet, as you say it, and there are potentially more funding and resources. You did it without all of this, but it seems like it is harder. Is it that we lost our stamina and persistence, or why is it difficult now? Or is it that science has developed that most of the big ideas have already been taken?
The big ideas had not been taken. They are still out there. It's just to bring them into your brain.
I think that's the crucial thing. There's no shortage idea of big things.
No.
The world is full of big things most of the time. However, as people get older, like Mohammed, they then may close their vision a little bit. And we talked about that very early on.
Exactly.
We don't have all the answers to everything. Mohammed has been very good about that, saying, why don't we push this or push that, because we don't know everything about it. And that's the most important thing. Not everything that is known is either right, nor do we know anything about it.
No.
So I think that's a really important thing.
So it must be then, if I take the answer as by exclusion, then it must be that we have become less resilient and more narrow visioned, that we're not moving up with ideas. Or what was the reason?
I think that many of us nowadays, there's so much input coming from the internet and everything, but many ideas are rather simple. TAVI was a very simple idea. It was not complicated, it was simple. And such ideas can still come up. Very simple idea. But if you think about all the problems, then you don't do anything, because then you say, oh no, it cannot be done. Of course it can be done. Just go for it.
Yeah, so because I mean, a lot of people are putting up in the chat about you know, the excuse that there are more rules, more regulations now. It seems like it's not a whole lot different, maybe a little bit, but I mean, it seems like every inventor who has come up with something disruptive, they had to, you know, be persistent, and there were times when they asked for forgiveness and did some things to move the ideas forward. But do you think the regulations and rules are much different now, that it's harder to do things, or you don't think that's a factor?
Some things are maybe more difficult, especially within, let's say, clinical medicine. If you want to do clinical trials, there's a lot of requirements. If you want to do an experimental study like I did with TAVI, I think I could find out to do it with the same speed today. Maybe I have to cut a corner somewhere, but I could do it.
Amazing.
So tell us what your thoughts are. What are you going to do next then? How about that?
I'm still a little bit
off hand. Go ahead.
You know, I always, now I have to tell you, I'm partly, no, I am retired now. I'm more than 70. So I'm partly retired. Still have an office at the hospital, things like that. Sometimes doing things. Also have crazy idea, but I don't really go a lot into the animal. If I should do something today, I would go to the animal lab and do crazy idea. I have some, but I'm more retired than I'm a researcher.
Crazy ideas don't mean whether you're retired or not.
No,
Your brain,
that's right.
your brain doesn't retire.
Yeah, that's right. I fully agree.
So now this is, you know, summing up a journey of 30, 40 years of work that, you know, was inspiring. You pushed it forward, but there were a lot of disappointments along the road, and a lot of, you know, you sort of like got excluded from an idea that you developed and brought. And, you know, honestly, do you feel overall, are you more on the, is there more resentment, or are you more satisfied and pleased and content after these 30, 40 years, seeing, you know, seeing what has happened to you and seeing how many hundreds of thousands of procedures that have been done, including the one, you know, happened that was done to your father, your own father. So is it, do you have more satisfaction or resentment now?
I think it's very, very rewarding as a physician to see your own baby being developed. And I say today, this is my baby. Today it is a young teenager, but it will mature, and it will also be here 10 or 20 years from now. It's not so many inventions within interventional cardiology who stays here for so long time. I've seen several inventions coming up, being used for a few years, and then they disappear again. I'm convinced that my invention will also be here when I die.
How so people then will come to you, people that you mentored. What do you tell those people? What are the things that they should be on the lookout for? How to make them really open to these sort of things that you have done? What do you say when they say what they should do?
Yeah, they should do, of course, they should do like I did. No, the best way of explaining it is actually try to start with telling your own story. And then to speak out from this, because it is the best way of convincing young people that it can be done. You don't have to sit there and brave and say a lot of beautiful things, but the basis is that, look what I have done. I was successful with this idea because I did like this and this and this. And then you can advise the young people that they should have this approach or attitude towards life and towards science. And I think for me, it's very good to make this proof that I have done it myself. So at least this is one way to do it.
You know, simplicity is the ultimate complexity, and as you say, just telling the story that I've done it, and it started with a simple idea. I was a medicine intern. I really didn't have much knowledge in the field. I mean, amazingly, you went to the butcher shop and sewed in the valve without knowing actually even about the leaflet. So we're coming to the end of the hour, and I mean, this is so interesting that I would hope that to continue for another hour, but I think I want to respect your weekends too. It's already dark in South Africa. I could see from behind Dr. Holmes. So
Right.
maybe a closing comment from David, and then from Dr. Anderson. David, do you want to give us a closing comment for
I think
you advise the
I think the most important things that we learn are that dreams are real. We need to be able to dream, and we need to be able to imagine. We will only be limited. This somebody else said, but it's a wonderful quote. We are only limited by our imagination.
Yeah.
With our imagination, we can create, and we can change, and we can do amazing things like this, and we can learn from others, but imagination is the thing that holds us back. One of the things that we need to remember as we grow up our kids is for them to dream. Goodness sakes, go for it.
Yeah.
And it is that we're only limited by our ability to imagine and dream, and then work hard to make it happen. Persistence.
Yeah.
So yours is a wonderful story, man.
It's only the sky who is the limit, right?
Exactly right.
Yeah.
Exactly right. And in this day and age, it's not even the sky that's the limit. We just saw that the explorers or the people have been able to identify the black hole.
Yeah, that's
through
right.
which 44 million suns go, and we now can see it.
Yeah.
And somebody comes up with a wonderful idea like yours, and persistence to make that dream reality. So yours is a wonderful story. Thank you.
Thank you. Thank you.
So Dr. Anderson, it was wonderful to have you. We really appreciate you. Do you have any final words to say? We would love to see you here, hopefully sometime soon, but we really appreciate
you again. I will say see you again someday.
All right, great.
Perfect.
Have a great weekend all. Thank you very much
for
joining us again.
Thank you so much.
For this is Minnesota, and we'll post it on the website. Bye.